So the major objective that we'll have today will be mainly around the product rule, quotient rule, and something called a chain rule. So these are the three important things for additional maths and the kind of AS level courses also. So what we have is, first thing is that let's do some warm-up questions on this formula that we did, and then we start with the fresh stuff. So let us say if you have, for example, this expression and you want to find out the derivative for this expression. So now, since we have a formula for x to the power n as nx to the power n minus 1, we're going to just apply to this. Now, since you can see that this is not in the standard form of x to the power n, we need to break down each term by expansion. So my first step is to expand each of them. So here, if I look at x squared, the whole squared, a squared plus twice ab plus b squared. So I'm expanding each terms very carefully, and you get is x to the power 4 plus x and this x get cancelled, and you get 8x and plus 16 over x to the power 2. So this is the simplification for this. And what we get is, we get x to the power 4 plus 8x. And if I modify this, because you need to bring to x to the power n format. And here this is in denominator, so it'll become 16x to the power negative 2. Now our next step is to differentiate like each term and then add them up. So x to the power 4 derivative. Now you write down the derivative expression. Dy by dx will be, first one is n, if you see is 4, so it'll be 4 x to the power 3. So 4 x to the power 4 minus 1 and plus 8x. Now 8 times 1 times x to the power 1 minus 1 and plus 16 times negative 2 x to the power negative 3. So this is the derivative of the first part, which is 4x cubed plus 8 minus 32 over x cubed. Now the second one is where you have x squared plus root x over x. Now I'll do x squared over x, first isolated, plus root x over x. So what I get is, I get x here, and then root x over x can be simplified as, root x can be written as, x can be written as root x squared. So one of the root x get cancelled. So get x plus 1 over root x basically. And this becomes x plus x to the power negative half. Now, when you do the derivative for this, your dy by dx will be derivative of x, x to the power 1 if I have, so it will be 1 x to the power 1 minus 1, which is 1 x to the power 0, which is 1. So that's why derivative of x is 1, plus derivative of x to the power negative half will be negative half x to the power negative half minus 1, which will be 1 minus half x to the power minus 3 by 2. Now, what we get is from here is 1 minus half x to the power 3 by 2 basically, and which you can write down as like 1 minus 2 root x the cube. This is like the simpler version for this. Now third one is when you have y equals to x cubed times 1 plus x squared, you would like to open it up. So it'll become x cubed plus x to the power 4 plus x to the power 5. So when you open this up, so x cubed times 1 is x cubed times x is x to the power 4, x cubed times x squared is x to the power 5. Now when you do dy by dx here, so dy by dx here is 3x squared plus 4x cubed plus 5x to the power 4. So that's the derivative of basic questions based on this formula logic. So the major objective for today's lesson is to understand, number one is the different types of expressions, that different expressions, derivative expression, like different functions that you have for different like derivative. Then you have product rule, quotient rule, and last is chain rule. Now, The other different functions that you have, like for example, I'm just writing these things like f of x and their derivatives. Now x to the power n derivative is n x to the power n minus 1 as we got. And now the other ones that you have to remember, I mean, it's good to remember that even though they are on cover page of your like question paper, e to the power x function. Whenever you see e to the power x function, the derivative e to the power x is as it is. E to the power x is e to the power x. Then you have derivative of ln x function. Derivative of ln x is 1 over x. Then derivative of sine x is cos x. Derivative of cos x is negative sine x. And derivative of tan x is 1 over cos square x, you can remember, or sec squared x. So this is the basic functions that you need to study the derivative for. So our next stuff is to actually understand what are the different kinds of questions that can be assessed. So first, let's take some of the easier ones that use the multiple functions for these. So let's say if I have y equals to 3 times sine x minus like 4 ln x plus let's say e to the power x plus let's say tan x. This assume that this is my function. And I want to find out the derivative for this. So what we do is your dy by dx will be derivative sine x, as you can see, is cos x, will be 3 times cos x minus 4 times derivative of ln x, you can see, is 1 over x, minus 4 times 1 over x plus e to the power x derivative, if you see e to the power x, e to the power x will be as it is, and plus derivative of tan x is here 1 over cos square x, which is this. So this is the basic like usage of the different types of functions. But now the problem is that if you have been given, let's say, to differentiate something like this, if I have, for example, if I have x times sine x, or for that matter, ln x, x squared times ln x, or for that matter, I have like e to the power x times sine x. Now when you see the product of two different functions, in this case, how do we find out the derivative? For such case where you see a product of two different functions, what we have is, we have something called as product rule. Now in product rule, assume that, now this need to be understood very carefully, if I have y as a function of product of two functions, let's say y is product of u and v. So u and v, these are the two functions of x. Like here, for example, this is my u and this is v. So u is x and v is sine x. How do I differentiate the two functions? So when you find out the derivative, the formula is uv dash plus vu dash. Now what does this mean? Keep the first function as it is, differentiate the second, then keep the second function as it is and differentiate the first and add them up. So that's your product rule. So when I take u here, u will be x and v is sine x. Any one of these you can take, vice versa also is fine. You can take u as sine x and v as x, that's also okay. Now, first thing I need is u v dash. So let's say u dash is like derivative of x as we did is 1. In case if you don't know, x to the power 1 minus 1, it is 1. So remember in now short as the derivative of x is 1. The derivative of v, which is sine x derivative, is cos x. So the derivative of sine x is cos x. Now when you put in the formula, let's say I plug in this formula, dy by dx will become u, which is x, so x times v dash, which is cos x, plus v is sine x times u dash, which is 1. So it will be x cos x plus sine x as the derivative for this particular function. So for the second part, which we have is, let's say u is x squared and v is ln x, for example. Now u dash will be 2x, x squared derivative is 2x, and ln x is, the derivative of ln x is, v dash is 1 over x. So v dash x is 1 over x. That's your, because from here you can see ln x derivative is 1 over x. Now the derivative of final answer will be dy by dx will be uv dash, so will be x squared times 1 over x plus vu dash, just like uv dash plus vu dash, cross multiply them. So it'll be 2x times ln x. So it becomes x plus 2x ln x. That's your derivative for this particular function. Now the third one is you have e to the power x sine x. Now when you have e to the power x sine x, what we have is, let's say u is e to the power x and v is sine x. So u dash will become e to the power x as it is, and v dash is cos x. So when you do the final derivative, it will be uv dash will be e to the power x cos x plus vu dash will be sine x times e to the power x. And if you want to take e to the power x common, it will become cos x plus sine x. So that's the derivative function for e to the power x sine x. So quotient rule is basically now like how we had got product of two functions and we were doing the derivative for it. Now quotient rule is same way if you have division of two functions. Like for example, if my function is sine x over x, or for that matter, if it is ln x over x, for that matter, it is e to the power x over sine x or vice versa. So these are the functions, like how do we do the derivative for this case? Now, we have something called as quotient rule. The proof is not expected. In case if your function is y equals to u over v. Now, remember that in this case, you always take numerator as u and denominator will be v. Numerator is u and denominator is v. So when you find out the derivative in this case, your dy by dx will be written as, this is a formula which you got to remember, v square as it is. Like you square the denominator, write v as it is, then derivative of numerator, which is u dash, minus u as it is times derivative of denominator. So vu dash minus uv dash over v square. So for example, if I'm taking, let's say, ln x over x, one of the like favorite questions for exams. Here I will take u is ln x and v is x. Now what you need for the formula is u dash and v dash. So just find that out. So u dash is 1 upon x, v dash is 1. Derivative of ln x you can see is 1 upon x. Derivative of x, as we did so many times, now I would expect that you remember this. Derivative of x is 1. Now plug in this formula. So dy by dx according to this formula will become v squared, which is my denominator. So x squared, v as it is, so x as it is, you can see v is x, times derivative numerator, which is ln x, which is 1 upon x, minus u as it is, which is ln x as it is, times derivative of v, which is 1. So if you cancel this out, we get 1 minus ln x over x squared. So now if you have y equals to, let's say, sine x over x, for example, and you want to do the derivative. So here, let's say u is sine x, and let's say v is x. So first thing is that like dy by dx will be v square in denominator, so it'll be x square, x as it is, times derivative sine x, which is u dash is derivative sine x is cos x, minus u as it is, which is sine x as it is, times derivative of u, which is 1. I mean v, which is 1. So it'll become x cos x minus sine x over x squared. So y equals to, let's say, e to the power x over sine x if I have. Now, what you'll have is that u is e to the power x. So, and v is sine x. So u dash is going to become e to the power x and v dash is cos x. Now, when you want to do dy by dx, it'll be v squared, which is sine x the whole square, which is sine squared x, sine x as it is, times derivative of u, which is e to the power x itself, minus e to the power x times derivative of sine x, which is cos x. So if you wish to take e to the power x common, it will be sine x minus cos x over sine squared x. So that's the derivative of this function. Now, chain rule is something which is about the derivative of composite functions. Now, when you talk about the composite functions, like obviously it comes like f of g of x in your mind, g of f of x in your mind, and so on. What I'll be doing is, for additional mathematics, what we have is we can link up with these formulas itself and see how and what kind of derivatives we can do using chain rule. Now let us say if I ask you to do the derivative of x to the power 20, we all will say, okay, the derivative is 20 x to the power 19. When I say derivative x to the power, let's say, or for example, let's say if you have sine x derivative, we can say, okay, the derivative is cos x straight away. So these derivatives we'll already know. But what if instead of x to the power 20, if I give you the, let's say, x squared plus 5x plus 7 to the power 20. Of course, we are not going to go and differentiate, I mean, to the power 20. We're not going to go until there and expand each term. It'll take forever to do that. So how do we differentiate such questions? For that matter, we did use something like this, like for example, to the power of 5 or something. Even expanding these is like a little bit of pain. So how do we tackle such expansions or such derivatives, which needs to be done? So what I would do is I would give a straightforward formula logic. First, we'll take around like, all 6 to 7 formulas for the chain rule, and then we will apply them in problem solving. I'll try to make as easy as possible, but if you have any difficulties, please do ask me. So let's say instead of x to the power n, if you have some function to the power n. So let's say now my new function, let's say g of x is, and this is g dash x. I'll leave this much space for doing the practice. So instead of, let's say, x to the power n, if I have some function to the power n, like how we got in previous case, that to the power 20, inside there was a function. In such case, how do we do the derivative? So what I would say is that consider here that x to the power n is the father function, and fx is inside that, you see, the child. So what I would differentiate is first differentiate the father function, like as if you're differentiating normal derivative or normal x to the power n. So it will be n f of x to the power n minus 1, n times function to the power n minus 1. Just after doing this step, do not forget to multiply with f dash x. It means that multiply with the derivative of the child function. Now, what it means to me. Now let's take through an example. If I have x squared plus 4x plus 5 to the power 20. So first, what I'm going to do is, this is the function here for me. I'm going to not touch in the first step. So it'll be 20 x squared plus 4x plus 5 to the power 19. So first step is you differentiate the normal, like, the way we do like normal x to the power n times the derivative child function. The child function here is this, which you all will agree that it is 2x plus 4 and derivative 5 alone will be 0. So that's the derivative, and which simplifies to 20 x squared plus 4x plus 5 to the power 19 times 2x plus 4. So now let's take a couple of more examples on this particular part where you have been given some function to the power n. Now, one of the favorite example is involving the roots. Let's say if you have square root of x squared minus 3x plus 2 or something. Suppose this is my function. And you want to find out the derivative for this. So once again here, what we have is y can be written as x squared minus 3x plus 2 to the power half. And you can see that here the father function is like square root x function. And inside the child is x squared minus 3x plus 2. So once again, if you compare, this is my f of x and n out here is half. So when you do the derivative for this particular question, you do n, which is n half f of x, which is x squared minus 3x plus 2 to the power half minus 1, which is n minus 1 times derivative of fx, which is this one, which is 2x minus 3. Because x squared derivative is 2x, minus 3x derivative is minus 3, and plus 2 derivative is 0. And as a result, you can simplify this to 1 over 2 x squared minus 3x plus 2 to the power negative half times 2x minus 3. So if you further simplify this, it can be written as 2x minus 3 divided by 2 times root of x squared minus 3x plus 2. The reason is that this comes down and becomes power half, and power half is nothing but the square root. So this is the derivative of this particular function. So now let's take an example which is like one of the special example that kind of additional mathematics paper you will frequently see, something like this. X squared plus, let's say, 4 over x to the power maybe around 5. Now, if we want to differentiate this, or for example, let's say if I want to differentiate sine cube x function, all these fall into the category of the first one, which is f of x to the power n function. Now, once again here, if you see the parent function is x to the power 5, and the child function is x squared plus 4 over x. So here again, this is like my f of x, entire thing is f of x. And now let's do the derivative for this. So the derivative will be dy by dx is going to be 5 x squared plus 4 over x. The first step is like, don't touch the child at all. So to the power 4 times the derivative x squared plus 4 over x, which is going to be, once again, you need to be really careful. X squared plus 4, I can modify like this. So the derivative x squared will be 2x, and derivative 4x to the power minus x will be negative 4, because negative 1 comes here. Negative 4 x to the power minus 2. So 5 x squared plus 4 over x to the power 4 times 2x minus 4 over x squared. That's the derivative of this part. So this is n fx to the power n minus 1 times f dash x. Fx here you can see is this, and you can see its derivative is here. So that's how you basically find out the derivative of the first one. Now when you talk about the second function, which is sine cube x. Now sine cube x, like can be written as, this is same as sine x the whole cube. So here my parent function is x cubed, and you can see the child function is sine x. So our first step will be to derivate this parent function, which is 3 sine x the whole square. So n fx to the power n minus 1. So I didn't touch this fx at all in the first step. Times derivative sine x, which is cos x, which is the derivative of fx. So the derivative of fx is sine x derivative, you can see, is cos x. So this is the derivative of sine cube x function. So in this example, first what we'll do is we'll just modify this to 3 times 5x squared minus 6x plus 7 to the power negative 3. Before you do the derivative, so get that in the form of fx to the power n. Now since this 3 is a constant, we don't touch it. Okay, so dy by dx, when I do this, it's going to be this 3 as it is. Then you have n, it will be negative 3 fx, which is 5x squared minus 6x plus 7 to the power negative 4 n fx, n fx to the power n minus 1 into derivative child function, which is 10x minus 6, because 5 square derivative will be 10x, minus 6x derivative is negative 6, and 7 is a constant number whose derivative is going to be 0. So this is how you do the derivative of the particular this particular function. And of course, after this, you can simplify this. It will be negative 9, 10x minus 6 over, you can write down this will be 5x squared minus 6x plus 7 to the power 4 in the denominator. So now let's take the next example, which will be 1 over root of 4 minus 3x squared. So first you write down this as, modify this as 4 minus 3x squared to the power negative half, because root is to the power half. If you take up, it becomes to the power negative half. And here your dy by dx, so your dy by dx is going to become negative half 4 minus 3x squared to the power negative 3 by 2. So negative half 4 minus 3x squared to the power negative 3 by 2. How do I get this negative 3 by 2? So it's like n, which is negative half fx to the power n minus 1 into the derivative of child function, which will be minus 6x. Derivative 4 is 0, derivative minus 3x squared will be minus 6x. Now this n minus 1 when you do, so minus half minus 1 is minus 3 by 2 into minus 6x. So this negative and negative get cancelled. Negative get multiplied to positive. 2 and 6 get cancelled, so it's like 3x here. So it'll be 3x times 4 minus 3x squared to the power negative 3 by 2. And of course, you can bring it down and simplify as positive indices. So now let us say if we have got, instead of e to the power x function, if I have got, let's say, e to the power, let's say, fx, instead of e to the power x, if I have got e to the power fx, it will be e to the power fx itself, because you can see the derivative e to the power x is e to the power x. So e to the power x will be e to the power fx will be e to the power fx as it is, but into the child function, which is derivative of fx, which is f dash x. Now, what does it mean to me? So let's say if I have e to the power x squared plus 5x. Now this no more looks like e to the power x original function. So we have got e to the power fx here. So e to the power fx derivative will be e to the power fx, which is x squared plus 5x. So first time you differentiate is like your parent function, but into derivative x squared plus 5x, which is going to be 2x plus 5. So that's the derivative. So you just see, like, make sure that the derivative is multiplied not in the power, it is times the function. Now let's say if I have got e to the power sine x function. So once again, the parent function is like e to the power x. So we'll do e to the power fx will be e to the power fx, e to the power sine x times derivative sine x, which is cos x. Now let's say if I've got e to the power of 4x cubed plus 2x squared plus 7. So when you differentiate this, it'll be e to the power 4x cubed plus 2x squared plus 7. First step as it is, so e to the power of x is e to the power of x, but into the derivative of fx, which is the child function, which is 12x squared plus 4x. When you have the ln x derivative, okay, now if x has been replaced by, let's say, child function, let's say ln of some function. Now in this case, our derivative will be once again 1 upon f of x. So 1 upon the child function, like you can see 1 upon everywhere, wherever I have x. In the first step, I have differentiated it as like 1 over fx, but do not forget to multiply with the derivative of the child function. So this multiplication by the child function derivative is throughout. Only thing is that you just follow the backbone of the parent function, multiply with the derivative of the child function. So let's say if I have got ln x derivative, we all know that the derivative of ln x is 1 by x. Now, if instead of ln x, if I've given you a function, let's say ln of x squared plus 3x plus 5 or something. Now, in this case, what is the derivative? So when you differentiate this, we have like the child function of this. First step is 1 upon the child function. So 1 upon x squared plus 3x plus 5 times the derivative of the child function, which is 2x plus 3. Let's take one more example. If you have ln of 4 minus 3x, let's say I want to do the derivative for this. Now, this will be 1 upon the child function, because 1 upon the child function, 4 minus 3x times the derivative of negative 3x, which is negative 3. 4 minus 3x, which is negative 3. 4 derivative is 0, negative 3x derivative will be negative 3. So that's how you do this. So now the next part that we will do is basically that involves a little bit of, I mean, the parent function is ln x, but that involves the identities of the logs, the log properties. So let us just see a couple of questions, like, which might help you to figure out something much more easier. So let's say if I have to differentiate ln x squared minus 4 over x squared plus 3x, x squared plus 3, 3x plus, let's say, 2. Now, when you do this question, it's going to be like without log properties, it'll be like 1 over fx will be 1 over x squared minus 4x over x squared plus 3x plus 2, and then into the derivative of x squared minus 4x upon x squared plus 3x plus 2, which is you'll have to do by quotient rule. So to avoid these situations, like what we can do is we can also use the log properties here. So log property will be, if you remember, it is ln a over, sorry, this is not log, this is ln. So if it is ln a over b, it will be ln a minus ln b. So if I apply that here, so I can write down ln x squared minus 4x minus ln x squared plus 3x plus 2. So when you do chain rule here, so what we get is dy by dx in this case is going to be 1 over x squared minus 4x, 1 upon fx into 2x minus 4, that's the first part, minus this derivative now, 1 upon the child function, x squared plus 3x plus 2, into the derivative child function, which is 2x plus 3. And of course, you can write down this as 2x minus 4 over x squared minus 4x minus 2x plus 3 over x squared plus 3x plus 2. So that makes our life much more easier. So let us say now if I have, instead of sine x, if I have some, let's say sine is my parent function, but there is a child function sine of x. Now, first step is we'll do the normal derivative, the cos of the child function into the derivative child function. Just remember that. Similarly, if I have cos of the parent function, cos is the parent function and fx is the child function, so it'll be negative sine of the fx times f dash x. Similarly, if I have the tan of the function, tan of fx, it'll be 1 over cos square fx into f dash x. So let's just take an example. Now, for example, let's just first work on sine x to cos x derivative. So derivative sine x is cos x. If I have got, let's say, sine of x squared plus 3x plus 2, the derivative of this is going to be cos of x squared plus 3x plus 2. The child function, not derivative multiply, so it'll be 2x plus 3. So first parent function, you can see the derivative as it is. Like for example, if I have, let's say, sine of e to the power x. So sine of e to the power x here, e to the power x is the child function. It will be cos of e to the power x. First step is sine changes to cos, you can see. Sine of x is cos of x into the child function derivative, which is e to the power x derivative is e to the power x. Now, for example, if I have sine of cos x. So here sine is the parent function. So first step is don't touch the child. It will be cos of cos x into the derivative cos x, which is negative sine x. So the derivative cos x function, which is a child function, is negative sine x. So that you got to multiply with. Let's say if you got sine of ln x. So sine of ln x will be cos of the child function into the derivative child function, which is 1 over x. So this is the chain rule about the sine. And now let's just take a couple of questions on basically the cosine chain rule as well. So if I have like similar rule, obviously it applies, but just since they are different functions, I'm just doing a couple of questions. Now cos x to minus sine x. So cos x derivative is negative sine x. Now if I have cos of fx, as we can see, the child function will be fx. So it will be negative sine of fx into f dash x. Now let us say if you have cos of x squared, let's say plus 4x minus 3, it is going to be negative sine of x squared plus 4x minus 3 into 2x plus 4. So that's your derivative function here. Negative sine x squared plus 4x minus 3 times 2x plus 4. So first time I didn't touch the child function into, like after I completed the parent function derivative, I did the derivative child function, which is 2x plus 4. And derivative 3 is 0. Similarly, let's say if your cos of tan x. So here tan x is the child function. So cos x derivative will be minus sine of tan x. So child function I didn't touch first step into derivative tan x, if you see, 1 over cos square x. So that's how you do the basic derivative of sine, cos, tan composite functions.